So if you take your tetrahedron and unfold it and lie it flat, the triangle flat on your desk, prefer to be on the side in which there's no writing. And what we're going to do is we're going to take this triangle that's been divided up into 4 congruent equilateral triangles, and we're going to continue to divide each triangle in a very similar way. This idea is called an iteration. It's where you start with a triangle or shape, you apply a pattern to it, you continue to use that same pattern over and over again to create a new shape. So in this particular problem, what we're going to do is we're going to take the 4 triangles and then the triangle that's inside of the equilateral triangle, we're going to shade that triangle. So on your triangle, I'd like you to shade out the middle triangle so that it's as though it's gone. And then what you're going to do is you're going to divide each side up into by finding its midpoint, and then we're going to connect the midpoints as we did in the original triangle to basically divide each of these triangles up into 4 congruent equilateral triangles. So this is called, in geometry, we call this an iteration. It's the idea of taking a pattern and or a rule and applying that same rule over and over again. So now we have smaller copies of the bigger triangle, and again, using the same rule, we're going to shade the middle triangle of the 4. If you would use your ruler, or if you're using paper folding, if you would continue to do that iteration at least 1 more time. If you have enough time or space, want to do it 2 more times, that's great. But do 1 more time. And when you're finished, turn the video back on. So this is my final design. This is called a Sierpinski gasket. It's one of many monster curves that were created in the late 1800s, early 1900s, but they started to gain some popularity in the 1980s and 1990s when a gentleman who worked for IBM looked at these shapes and started to change some of the rules, and in doing so, he came up with a new geometry called fractal geometry. So if you when you're finished with this shape, if you fold it right back up into a tetrahedron again, and think about all those triangles that have been removed, you've created basically is a Sierpinski solid that in some ways is being used today as an antenna for receiving information at a football stadium, such as an NFL football game. Among the geometries out there, there's over 100 geometries, and Euclidean geometry is the one we've been primarily studying. And so I wanted to introduce you during this semester to some other geometries that are pretty popular, whether you are aware of their existence or not. I have placed in your Learning account a YouTube video that talks a little bit about the work that was done in using fractal geometry to create antennas for cell phones. Because without the antenna that's in your cell phone, which is a fractal design, you would not be able to do the things you're able to do today with your phones. Also, I have placed a website, or some information about a website called Fractal Antennas, which they are the leading company in the world in terms of fractal designs. So, if you're interested in learning more about fractal geometry, check out the information I provided in the page today. If you are interested in more information about fractal geometry, just let me know.